Again, my name's Steve Willoughby with Bentley Systems. What we're here to talk about today is we're going to focus on OpenBridge Modeler that's been out for about 1.5 years now, and we're going to focus on that from the perspective of a roadway designer or detailer. So let me go ahead and kick this off. I've got a few slides here, and then I'm going to go through the process of modeling a bridge live so you can see it. So feel free, like Natalie said, ask those questions in the Q&A window, and we'll interject some of those as we go, or we'll take care of all of them when we get done. Now, traditionally, bridge design has been a very disconnected process. The roadway folks have had their own information in their silo. The bridge layout's been its own process. Bridge design, 2D plans production, and so forth has all been very disconnected. And what we're going to focus on today is how we can get those connected, especially the first two here, the roadway and the bridge layout, and show you how we can take the same information that you're using on the roadway side today and use those to very quickly lay out a 3D bridge model. So if we look at it from an integrated data flow, bridge modeler being right in the middle, and that's on purpose, and that's part of our goal going forward, is for it to be the one place that you create a bridge model, and it will talk to whatever other product here within Bentley that you need to share information with. So whether you're doing detailing with Pro Structures, you want to do analysis and design with OpenBridge or one of the Leap bridge products, we can do all of that. But we can also pull information from the roadway design folks, whether they're using the Concept Station or the Open Roads platform for doing their work. So what is OpenBridge Modeler? So several years ago when we started with the product, what we did is we started with the most current version of MicroStation at the time, the MicroStation V8i platform. And then we went and talked to our roadway folks up in Huntsville and said, hey, here's what we need. We need alignments, we need profiles, we need the ability to do terrain models, we need superelevation, those types of things that we have in common with the roadway folks. There was no reason for us to reinvent the wheel there. And then on top of that, we added a set of tools specific to modeling a bridge, and then also, like I said, talking to our other bridge-related products as well. So again, some principal benefits here. The information that we can get directly from the roadway designers, the horizontal vertical alignments, the terrain models, the superelevation. And then interface-wise, we borrowed a lot of that technology as well. So things like the heads-up prompts that are in Open Roads, we use the same ones. We use the same task menu that they use. It's a very fast and easy modeling process. We use the same civil rules that they do. And plus, being on top of the MicroStation platform, well, that gives us a lot of other things too. So things like visualization, clash detection, quantities, undo, redo. Very simple concepts, but things that we get free along the way. Plus, for those of you using ProjectWise, totally integrated with ProjectWise, and I know DOTs that have set up OpenBridge Modeler to run even in a managed workspace type environment within ProjectWise with no problems at all. So here's an example of a bridge that was modeled. This was actually done last year, shortly after we came out with the software. This was modeled by a gentleman at Florida DOT. So the everything you see here bridge related, the railings, the piers, the beams, even on the other side of the bridge here, I'm going to stop it for a moment. You can see where he's added some pipes and some brackets here to hold these pipes. He did all that with OpenBridge Modeler, and then we just used LumenRT to kind of dress it up a little bit and make a little more realistic looking model here. But the bridge model itself was all completely done with OpenBridge Modeler. So how do we do that? So here's the interface to OpenBridge Modeler, and again, it's going to be very similar to what you're used to seeing with the roadway software today. We use the same Project Explorer that's in MicroStation. We call it Bridge Explorer, so we've added a couple tabs up there specific to bridge. Still have your task menu. Still use the element handlers. Of course, we have the 3D model that's being generated for you. Element information, we're putting a lot of intelligence on those elements. Plus, you can click on any element after it's been placed and go to its properties and make any changes that you want to make after the fact. So as far as the bridge types go, the two most common ones are here for sure. We have 5 total, but precast girder bridges and steel girder bridges, whether you use rolled shapes or what we call built-up plate girders. We can do those today. We can also do segmental bridges, either span by span or balanced cantilever. We can do cast-in-place boxes, and we can do cast-in-place slab bridges as well. So pretty much the bread and butter of probably 85–90% or more of the bridges that are out there on the system today, we can model here with OpenBridge Modeler. Now for the roadway portion, or for the deck portion of the structure, or the superstructure part of it, we do use templates for that. And it's very much the same template technology that's in, again, the OpenRoad software today. So we can build in some very powerful geometric definitions, unlimited relationships between the points, very graphical based input as you go. And we can even do some things here that the roadway side doesn't have yet. And as far as I know, looking at adding some of those capabilities on the roadway side. And we do give you some, of course, predefined templates, or you can create your own. On the substructure side, we have libraries for those as well. And of course, it comes pre-populated with quite a few different ones, but you can create your own. But we have abutments in there, stem walls, pile cap, user-defined shapes. For piers, we do have wall piers in there, multi-column piers, hammerheads, and we've added a lot of capabilities as far as the shapes of those piers and that, and being able to handle some of the more unique and architectural type shapes, as opposed to your basic round and square columns in that. So those capabilities are there, as well as wing walls, which were added just to the most recent version. So each time we come up with a new version of OpenRoads or OpenBridge Modeler, we're coming out with new versions of the analytical products, keeping everything synced up, but generally doing about 2 to 3 releases a year on each of these. So what I want to do is I'm going to open up OpenBridge Modeler and start the process of modeling a bridge here. So let me open that up. Okay, so here's our OpenBridge Modeler, and I'm actually in an empty MicroStation drawing, and I just simply have referenced in here currently a topo file, just kind of showing me some of the existing topo that's out there. It kind of gives us a general idea of where we're at on the project. And then I'm going to reference in an alignment and profile, as well as a terrain model. Now, again, we're assuming these are in kind of an OpenRoads format. So, whether you're using like InRoads or GeoPack or MX, in the kind of SS4 realm there, SS3 or SS4, they store all their geometry in a MicroStation drawing. So we can simply reference in that information. So I'm going to go up here and grab. So this file has my alignment and profile in it. And then I have another file here that has my existing terrain model in it. And I'm just going to attach those via coincident world here and select OK. And I can see that those come in right away. So here's my alignment. You'll notice when I hover over it, it's got a name. It has a profile related to it. And then, of course, here's my terrain model that we can turn on contours, triangles, wherever we want to see later on. If you don't already have those in an OpenRoads format, we have the tools up here at the very top for importing those in. So we can import in the geometry or the terrain model very easily here. Okay, so we have that. Before we can start the process of actually modeling a bridge, we do need that alignment and profile at a minimum. So we do make available to you here under tasks. We do have all the horizontal geometry tools and all the vertical geometry tools, as well as I mentioned earlier, the terrain modeling and superelevation are here as well. So everything you really need to model the bridge is all in one place. So I'm going to tell it that I want to add a bridge to the file here. The main thing you need to do is just tell it what type of a bridge do you have. Is it a pre-stressed reinforced concrete girder bridge? Is it steel girders, a slab? What type do you have? You just give it a name if you like, click on the alignment and accept it, and now you're ready to go. And we have, like I said, a ribbon interface across the top here, so it makes it very easy to kind of work through this, basically left to right through these tabs. So I'm going to come in here and set what we call pier lines, and basically these tell the software where all the piers and abutments are located. So I'm going to come in here and put in a station for this. And I already have it set up to the skew angle here. I'm going to have 100-foot long lines with about an 80-foot span. And I've got, excuse me, 9 pier lines total, so I'm going to have an 8-span structure. So I'll just click out here a couple of times, and I can see that it's getting ready to add these lines out here. Stops and asks me if I want to make any changes to any of this. Right here I could change skew angles, span lengths, stations, whatever I want to change. When I click OK, it goes ahead and adds those pier lines out there for me. So at this point, now we can move on and go to the superstructure tab. And we take a top-down approach to modeling the structure. So the first thing I'm going to do is place the deck out there. So I have selected here a template from our library. And the library comes with some basic slab decks out there. And then we have some segmental boxes out there as well. And then I've done some custom work for Virginia DOT. And so we have some special slabs out there just for them. I'm just going to pick our basic slab here. I'm going to tell it that I do want to add some constraints to it, and we'll show you what that's about in a moment. And then it simply prompts me to select the first and last pier line and accept them. And since I've told it I want to add constraints, I can now come in here and do either point constraints or variable constraints for any part of this template. And so with the point constraints, for example, I can take either 0.1 or 0.5 right here, and I can assign it either a horizontal alignment, a profile, or both. So that's one way of controlling, let's say, the right or left edge of the deck slab. Another way to do it is with simply variable constraints. If it's just a constant width all the way through or a very simple taper, this may be just as easy of a way to go. So I'm going to tell it for both of these, my bridge is actually 22 feet wide. So I'm going to come in here and change the left and right variables here to be 22 feet at both the beginning, which is the start value, and at the end of the structure. When I select OK, it'll go ahead and model that deck out there for me. Now in the top view it doesn't really look like a whole lot, but over here on the right I can zoom in and see the deck has been added, and then I can come in here and view this side in maybe, let's say, an illustration mode here, and we'll turn up the brightness a little bit so we can kind of see that bridge deck out there. So I'm going to rotate this view around a little bit so we can see that bridge deck kind of placed out there relative to the rest of the project. And at any point here, if you've already modeled the roadway, at any point you could come down here to references, and you could come in here and attach your 3D corridor and see how does that relate to the bridge deck here. So let me just go ahead and do that real quick. I have a corridor here. I'm going to go ahead and open that up and attach it. We'll give it just a moment to come in here. And then that way we can kind of see the bridge deck relative to that corridor. Now as far as the rest of the work we can do here, we could assign Superelevation. Again, we use the same Superelevation tools that are in the Roadway software. So it's simply a matter of clicking on that Superelevation shape out there, select the bridge deck and accept it, and it'll come up with a window and show you how it's going to change the cross slope on the left and right sides of the structure, and you accept it and immediately updates that bridge deck for you. I'm on tangent here, so I don't really need to worry about that. Next up, it asks me to lay out the beams here. So this is to get the beams out here is a two-step process, very simple one. The first step here, we simply define kind of in bridge terms, a framing plan. Basically, where's the center line of all the beams at out here in the view. So I'm going to tell it all my spans are going to be the same. So I'm going to turn on the little set all as default here, and I'm going to tell it that I'm going to have 6 girders here. And it initially puts the left and right girders on the left and right edge of slab, and then equally spaces out the interior girders. And then I'm going to change that offset for the outer girders here to 3 foot. So it's 3 feet from the left and right edge of deck to the center line of the first girder on each side. And if you want, you could add maybe a spacing here, since these are precast girders. Typically they have 1 to 3 inch maybe space or a little more. over each of the piers. So I'm going to go ahead and apply that. I don't really need to skew the ends of the beams since my supports aren't skewed, but we can do that. And I don't really need a corded layout here either. So I'm going to go ahead and save that. And what the software does is we place these dark green lines out here, and you can't really see the text too well with my white background, but if I hover over it, you can. And show me where the center lines of all the beams are and the names of them. And again, any of these things, once they're placed out here, you can always go back and change something later on. For example, if I click on this pier line, it shows me the skew angle and the station of it. And if I just hover over it, I can look at its properties and see all that information. And I can easily click in here and change anything about this pier line here. Or it's kind of hard to see with everything going on here, but there's a little arrow here. I can grab this pier line and literally drag it along the alignment and move it somewhere else. And everything affected by that. The beam layout, the lengths of the beams, the length of the deck, the barriers, everything else affected by that would update pretty much instantaneously as I do that. So next here, I'm going to come in here until I want to place some beams out here, and it just asked me to pick that beam layout that I just did, so I can hover over anywhere in here and click on them and accept them. And now it's going to come up and want to know, what I already told it I'm doing precast girders, so it defaults to pulling them from a LeapBridge concrete library. So it uses the same library that's in our current version of LeapBridge concrete. You can use that same library here today in OpenBridge Modeler. So I'm just going to come in and select one of the beam shapes that are already out here, this NU43, and I want to tell it that I want a 2-inch haunch for my minimum haunch, and that's going to help the software figure out the elevation at each end of the girder based on that minimum 2-inch haunch. And it's the default for all the beams here. Doesn't have to be, but it is in this case. So I'm going to go ahead and say OK. And it's going to go through the process of those 48 girders, figuring out, okay, it's just going to walk along each of those and figure out, okay, where's the minimum haunch on each of those, so it can figure out the elevation at each end of the beam, and then it goes ahead and adds the beams to the model here. So if I rotate this around, I'll go ahead and rotate this around a little bit, and we can see that the beams have indeed been added out here. Now, if we go back to the Project Explorer we mentioned earlier, if I drill down into here, I can see, so far I've defined a deck, we've laid out the beams, we've drawn the beams, and we have the pier lines out here. And if I want to turn the display of any of those on or off, it's as simple as clicking on one of those like so. So now I can see just the beams out here, for example. Now in real life, we know we can't have the beams floating out there in space. We need something to hold them up. So I'm going to go onto the Substructure tab here and place some piers and abutments out here real quick. And that's typically easiest done from the top view here, because I'm going to have to select some pier lines. So here in the Place tool, I already have a default abutment selected here. But again, this is just from a library that is user modifiable, where you can go in and set these things up and make them look any way you like. So there's my just kind of a simple little pile cap abutment there. So I'm going to say I want to select that, and I'll pick the first pier line here and accept it, and it gets added to my model out here. So to see it a little better, let me just turn off this roadway corridor for a moment, and we'll rotate this view around a little bit so we can see it. So there's our initial abutment that's been added out there. Now let me rotate the view back around, and we'll also get to see it add one out here at the end. So I'll come out here and pick the last pier line and accept it and see that it's added that. And then for the piers themselves, now before I add those, ideally I need to tell the software about my terrain model that's out here. So I'm going to go back to Bridge Setup real quick, and there's a little button here called Active Terrain Model, and I'm just going to pick on the edge of this terrain model here, and now the software knows that's the active terrain model. And the primary thing we use that for is when we go to place piers. When I go to place the piers, I can turn on something called elevation constraints here. So I'm going to come in here and pick a pier template. So let me go down, maybe we'll pick maybe something simple, one like that. So I'm going to select that, And then I want to do something called elevation constraints, and we'll see in a moment what that's about. So I'm going to pick all these interior pier lines. Accept them. And at this point, I can control the slope on the top of the cap, or I can say, you know what, just make it level, horizontal all the way across. But I can also do something with the footings here. So I'm going to say I want those, let's say, 4 feet below the terrain model. So now what it's going to do is it knows there's 2 columns on each of these piers, and it's going to figure out the elevation on the ground. It's going to subtract 4 foot, and that's what it'll place the top of the footing at. So in effect, the column length is going to vary on all of these. So I'm going to go ahead and select OK. So now it's going to walk down the alignment, and for those 7 piers, figure out where is the ground relative to the pier. And then we can see when I rotate this around, we have a variety of different column lengths here. And if I go in, I can, of course, come in and I can select the terrain model and go to its properties and tell it, hey, I want to override the symbology just like the Roadway folks do. And I want to go ahead and turn on the triangles here. So now we can see this terrain model relative to our structure out here. So this, again, makes things look a little more realistic here as far as what's going on. Now at this point, there's other things you could certainly do to this model. We do have wing wall tools up here, for example, where you can come in and add wing walls to the structure. So if I zoom in down here, I can come in and select the abutment and accept it and have it add wing walls out there. And let me do the same at the other end here as well. Okay, so if we want to zoom in and see those, let me turn this terrain model back off real quick for you so you can see those a little easier. But it has added some wing walls right in this area for us. So you can kind of see it right here, but if I get in and rotate this around and maybe get up underneath here a little bit, now we can see them even a little better. So there's the wing walls that were added to this overall model. Okay, so one other thing I want to do out here real quick is I'm going to go ahead and add a barrier to this bridge. We don't really want anybody driving off of here, so to make this a little more realistic, I'm going to come in here with a place barrier tool and select the deck and tell I do want to place a barrier out here. And again, that's from a template library. And this barrier can be placed relative to your alignment, or I can pick a point off of the template. So in this case, this barrier is for the left edge of my deck, so I'm going to place it relative to point P5 out here and say OK. And then it's added that out there, and I'm going to go back to place barrier one more time, and I'm going to say I want to do this also on the right side of my bridge. So I'm going to place a barrier on the right side, so I'll select the bridge deck and accept it. And I will pick the point that's on the right edge of the deck, which in this case is point P1, and accept it and say OK. And then we'll rotate this bridge model around one more time and show you that we do indeed have some barriers out here on this model. Okay, so pretty quickly, in about 10 or 15 minutes here at the very most, we've gone through the process of kind of explaining OpenBridge Modeler and what it can do, and then also showing you how you can very quickly get this bridge model out here. And remember, at any time you can come out here and modify anything about this bridge very, very easily. You simply come out here and you select on any part of this bridge. You can come out here and select this pier, for example, and hover over it and come in and change its properties and tell the software that you want to do something different with that particular pier, or that you want to change the width of the bridge deck, or that you want to change something about the barrier or put a different barrier out there. All those things are very, very easy to change. And even the location of the bridge. Most likely if you as a roadway designer are modeling this bridge, you may well be in a very preliminary phase of the project. And so things are going to be moving and changing on you. And we do have here under Bridge Setup a couple of tools just for that. There's an alignment button up here that if I need to pick this bridge up and move it to a completely different alignment, some alternative E alignment, I can do that. That alignment bridge button lets me just go pick a different alignment and it'll literally pick it up and move it over there. Or the move button here will take the bridge that I have here now. It'll hold all these span lengths and then move the bridge to a different starting station on the current alignment. So you do have some tools here to make some wholesale changes to this bridge very, very quick and easy. So with that, I'm going to open it up to some questions here. And actually, you know what, before I do that, let me point out I've got a couple more slides here I do want to mention real quick. As far as OpenBridge Modeler goes, think of it as our Bentleys BIM for bridges, okay? And what this is going to let you do, and you just saw it happen there very quickly, we can create one 3D parametric microstation-based bridge model very rapidly. We can kind of bridge the gap, so to speak, with the roadway engineers and use their reference alignments and profiles. That way, if the roadway folks, you as the roadway folks, if you change an alignment or profile that we use to model a bridge, I can go back to this OpenBridge Modeler product, click the update button, and it will inherit any changes that were made to the alignment or profile. So it makes communication and staying synced up so much easier. Whereas, you know, other products tend to import the alignment and profile, and basically they grab a snapshot of it at that point in time. Yet this OpenRoads technology is so amazing because we don't have to worry about that anymore. We can always keep things synced up. On the bridge side, it allows us to use the same model for analysis and design. It's literally a one-button press and say, I want to go to LeapBridge Concrete or LeapBridge Steel or RM Bridge and do all my analysis and design work. And you know, it gives us the ability to talk to our very bridge-specific analytical products. But we can also do steel and concrete detailing with this one model as well. We've worked very closely with our ProStructures folks in making sure that the elements that we create today will work in, for example, the Pro Concrete software, so you can do all your reinforcing detailing on the structure. We can create quantities and cost estimates from this one bid model, and if that's some way you'd be interested in seeing, I can very quickly generate that for you. We can use this one model for geometry verification and constructability. We can quickly manage all the project changes very efficiently, and we talked about those. And then we can plan and manage the whole construction process from here as well. So with that, I do want to go ahead and open it up to questions here, and see, and you know, would enjoy hearing back from everyone else. So I'll go ahead and stop sharing here for just a moment. Okay, one of the questions I see out here is how are curved bridges handled? Will it cord the beams for you? So we can certainly handle, you know, straight or curved bridges for sure. If you're doing a precast girder bridge, we will do cording of those beams for you. If you have a steel bridge, it's up to you how you want to lay that out. If you want to do a corded layout, or if you actually have curved beams, then we will do a curved layout for those beams, because our LeapBridge Steel analytical software will certainly handle straight or curved bridges of any type, whether they're eye girders or tub girders. So curves are certainly not a problem at all. And then I think I already answered this one. The next question was if the alignment changes, will the bridge update to the new alignment? And yes, we talked about that. So yes, we can absolutely do that. Back in, and let me go back to share my screen here real quick. Hopefully I won't lose the Q&A window here. But back here, this update button right here is what you will want to use to demonstrate that, or not to demonstrate that, but to update your bridge anytime, let's say an alignment change, the profile change, the train model change. You're simply going to come down here to your references, make sure that the reference file has been reloaded and updated, and then update the bridge, and we will redraw the entire bridge model based on the current geometry available to us. Okay. One of the questions was about the wing wall feature here. So they stated that their current version does not have wing walls. Yes, that was added in the July release of OpenBridge Modeler, so it came out around sometime early to mid-July. And we added a lot of things based on user feedback. Wing walls was probably the highest on the list. So we've added the ability to model a lot of different types of wing walls here, and they can be inline or skewed with the abutment, and you know, we can handle with or without footings, with or without pile. They can be rectangular, they can be kind of an elephant ear shape, they can be cantilevered out. We can handle just about any kind of a wing wall you want to see modeled as part of your structure there. All right, next one here. How do you get the pavement from the corridor to not overlap with the bridge deck created in OBM? So what I'm wondering is if that's maybe because you have a skewed structure or something like that. So what we can do, we can handle the skew just fine on the bridge side. On the roadway side for the corridor, you would actually have to use there's some clipping tools within, I don't remember if it's surface modeling or solids modeling tools, go in there and clip the corridor out so that it doesn't overlap with the actual structure. So otherwise it may be a matter of just taking into account where your pier lines are, because you can tell it where to start and stop that deck relative to the pier line. It doesn't have to begin and end there. It could be several inches to a foot one way or the other from that. So you do have some other options there as well. Next question here is, can you connect the bridge edges to a roadway edge line, or does the bridge only follow the roadway reference? Yes, we can absolutely connect the bridge edge up with the roadway edge lines, assuming they are you know, just your basic open roads horizontal alignments out there, or horizontal geometry. Back when I was placing that deck out there, there was an option there for point controls, and that allows us to take any point on that deck template and assign it to a horizontal alignment from OpenRoads. So yeah, we could certainly use the same types of things there. Let me see. Next question here. Can the software tabulate top of deck elevations over each girder at various increments? Absolutely, we can do that. So there is a on the reports tab, there is a deck elevations tool there, and it will certainly compute them along each beam line, along the alignment itself, at the gutter lines, at the edge of deck, at any increment you want, either a fixed spacing, or you can say just give me elevations at the 10th points or quarter points for each span, and we'll compute those elevations. Now in this newest version, we added a camber report in there as well, where you can either go in and key in the information about the camber on each of the beams, or if the design's been done in Leap Bridge Concrete, we can pull that information from Leap Bridge Concrete and use its camber information on each of the beams and generate a report for you, not only on the camber of the beams, but also on the buildup along each of those as well. Can we change the limits of the deck without getting the beams deleted? Well, the beams are placed kind of relative to the deck, but you shouldn't really lose things unless you actually delete the deck or something. But you should be able to change the limits of the deck, you know, as far as like maybe the, adding 20 foot to either end of it, for example, if you have an approach slab scenario. Instead of adding a pier line outside of that, if you just want to see that same bridge deck extended out past each end of the structure, you can change, there's on the properties window there's a starting and ending station offset where you could say make it start 20 feet before the beginning of the bridge and go 20 feet past the structure, and handle things that way. So let me go on down here. Does OpenBridge Modeler have any templates from DOTs built in? The current version does not. We just have those that we saw there a moment ago. But I do have, and I have posted videos out on YouTube on how to create templates, and it's really about a 4 or 5 minute video that goes through the whole process of how you create a bridge deck template. And if you've already have that template just drawn as a series of lines in, let's say, MicroStation today, when you go into that deck template tool to create your own template, you can copy and paste that from some other drawing into that window and use that template that you already have drawn there. And it works really well with that. Now, if you want, you can add additional constraints to it and give it intelligence so it knows how to handle things like width variations or slope variations or changes in deck thickness. But it is a pretty simple process to create. And now that I've mentioned that, we do have a lot of videos out there on YouTube now. If you go out and search for Bentley's I believe it's analytical bridge modeling or analytical modeling bridge. Excuse me. We do have a lot of videos out there, and we're in the process of adding more literally just about every day for all the bridge products, not just OpenBridge Modeler, but for a lot of the other products that you see here as well. Okay, one of the questions here is, can I show how to change the bridge width after it's modeled? So Natalie, if you'd let me, I'd like to go ahead and share my screen back out here and demonstrate that. So I'm going to go ahead and share my screen. Okay, so hopefully everybody can see my screen now. And so to change that bridge deck width after it's already been placed, it's going to be a matter of coming out here and selecting the bridge deck and changing it by either going to the properties window, or we can also do it from coming over here to the side and going to the properties here. And in the deck properties, here in the rules, here's where we could change those starting and ending station limits I mentioned earlier. I could also change the variables themselves that I've assigned to here. So I can come in here into the variable constraints, and so now it's open up. So here's my right width and left width, and then I could come in here and just simply type in a new value here. So let's say I make this, now it's 23.5 feet wide on the right side, and left side could be the same or different, right? So it's just simply a matter of keying in those new values and accepting them, and it's going to go through and widen that deck out. Now remember, the barriers were placed relative to the deck, so they're going to update as well. So it takes a little bit for it to kind of think about this, because not only am I changing the width of the deck, it's having to go through and update all the beams, potentially update the abutments and piers and all their elevations, and then update the barriers or anything else that's been placed relative to the deck here as well. So that's all it really takes to go through and update that here in OpenBridge Modeler. Okay, so let me go back to the questions here. I'm not sure. Usually I could see both these at the same time, but for some reason I'm having trouble doing that. So I'm going to have to stop the sharing here for a moment. And just I do it at updated. Anyway. Okay, one of the questions here is, where do the bridge designers do their plans production sheets? Here actually within OpenBridge Modeler, on the reports tab, we do have the ability to create sheets for the substructure and the superstructure. So there are some tools there for, and what we're doing is we're simply using and just kind of automating for you the dynamic view tools that are already available to you there in kind of a MicroStation or an OpenBridge modeler here, where you can take these 3D elements and slice through them and generate a plan view or a section view or an elevation view. But then we're also doing some basic automated dimensioning on those as well. So if you specify a dimension style, we'll go ahead and dimension the basic faces and elements that make up, let's say, that pier or that abutment, or it could be the superstructure. You can go out there and say, I want to generate a superstructure cross section right here, and we'll go out there and we'll label the slope on the deck and the width and the spacing on the beams and type of beams and things like that for you. So that's kind of our first attempt at it. Once we get on the Connect platform, MicroStation Connect platform, then we'll be adding a lot more tools and even jazzing that up quite a bit more from there. So. Okay, one of the questions here is how do we determine conflicts? Well, we have the clash detection tool here available to you. So the full-blown clash detection capabilities that are in, let's say, generic MicroStation are also here in OpenBridge Modeler as well. So we talked them into being able to include that tool with a license of OpenBridge Modeler. So it's simply a matter of going in there and selecting whatever level the beams are on, and then selecting whatever you want to compare that to. Maybe it's a roadway below, maybe it's a railroad track below, could be a stream crossing, whatever it is that you're wanting to check for conflicts with. We do have that clash detection tool there in the software available for you to use for that. Okay, another question here. We showed a turn-back wing wall. Can you model straight wing walls as well? Absolutely. In the Place Wing Wall tool, you have the option to pick, and let me see what it says here, either normal / skewed, where basically it's parallel with the alignment, or there's an inline / skewed option, where it would be in line with the abutment itself, and then you could specify a positive or negative skew angle from there if you needed to. Okay. Let me see what else we have here. So many good questions. How do we do approach slabs? Is there approach slabs in the package? So two ways to do the approach slabs. When you're placing the deck, like I said, you have the start station and end station offsets, and you could use that, and that might be good enough. If you need, let's say, a different shaped template for the roadway portion of that, then you could add a pier line where the approach slab begins and where prior to the bridge, and you could add an extra pier line out there past the end of the bridge, and come in with the place deck tool and just place a deck from that initial pier line to the beginning of the bridge, or from the end of the bridge to the end of the approach slab. And that way you could pick a completely different deck template if you needed to, and that deck template could vary, right? Because we know how to vary things now, either using variables or just simply drawing a horizontal line out there and saying, follow this line, and let that width vary if you need to. And you could also add, if you have sleeper slabs, some agencies place those out there. You would need to place a pier line to do that, but in the abutment tool, you could certainly parametrically model a sleeper slab and place that out there as well. So, will OpenBridge Modeler do bridge widening? Sure. Yeah. We should be able to handle any type of geometry that you have as far as widening out a structure. So as far as the horizontal geometry or vertical or both, we shouldn't have any problem doing those sorts of things. Does the surface need to be in the master DGN, or can they be referenced in? Assuming by surface you mean the terrain model, absolutely those can be referenced in. That's actually what I have here. So if I zoom out a little bit and hover over, oh, I know, I keep forgetting you can't see my other screen here. Those can absolutely be referenced in. So in a typical workflow, The bridge model is the only thing that's going to be in this file. Everything else will be referenced in the geometry, the terrain models, the superelevation shapes, the proposed corridors, if you have 3D models of those. All those are simply just going to be references in here. I mean, there's nothing we can't do here as far as referencing data. If you have aerial photos or files from context capture, you got your nice 3D model that you've brought in from a drone or something. Hey, there isn't, if regular MicroStation can reference that stuff in, so can we. So you have all those tools available to you. Let's see. You need to clip the entire corridor in the area of the bridge. Yeah, if your corridor is overlapping with the bridge because things are skewed, then I think you're just going to clip it for the full width of that corridor. I assume you could maybe do a portion of it. I've seen it done. I haven't actually done it myself, so I don't really have any way of really demonstrating that here today. But I know it can absolutely be done. Several questions on here about editing the proposed surface so that it wraps around the approach slab and things like that. So right now my proposed surface here from the Roadway folks is referenced in. So we would need to go to the Roadway software and make it aware of, let's say, those wing walls out there, and let it take care of wrapping around those, so to speak. Right now in the bridge, in OpenBridge Modeler, we're not doing any 3D modeling of, let's say, those slopes and that today, but you certainly have that full complement of tools on the Roadway side to handle any type of grading you probably need to do, let's say, around these abutments and that. So that's really where those tools probably best work. And I've even seen some folks have some civil cells that will help do some grading around abutments as well. Let's see, what else do we have here? Can we change the grade of the deck to not be on the center line? Oh, absolutely. Yeah, this the alignment itself can be anywhere, just like you would have in a roadway scenario. So if your alignment, let's say you have a divided highway and the alignment's down the median, but your profile grade line's over on interior edge of pavement or something like that. There's really no limitation on what we can handle there, when that deck is defined. So it's simply a matter, when you define a deck template, we have a concept of a working point, and that's going to help dictate where the alignment is relative to the rest of the structure there. So let me see, what else do we have here? One of the questions here is about, do you support joints and bearings? Joints, we don't really have an easy way to model those today. You can certainly add those maybe in as a cell or something like that, because we do have tools to help to place, let's say, 3D cells along the structure. So things like, whether it's joints, if you've got 3D scuppers, 3D light poles, 3D brackets like we saw earlier for utilities or signage, any of those things, we do have some specialized tools in here to make it easy to go in and place those 3D cells relative to, let's say, the bridge deck. But bearings, we do have tools for that. We do have a place bearing tool there on the substructure menu. So we can do cube-shaped barriers, we can do cylindrical. You can even have a 3D cell and have a very detailed looking bearing in there. And what we do when we place that, initially, and I didn't really show it in there, but when we initially place the abutments and pier caps, they're tied up against the bottom of the beams, and then when you come back and add the bearings, we'll lower the cap and just enough to fit in those bearings, whatever those are. So in the end, you should end up with some very accurate bearings or elevations across the top of the cap, and we can even generate like a beam seat report and give you some very detailed elevations on all those beam seats as well. Let me see, is there any other questions I've missed here, Sri, that we need to get to? I haven't really been marking them off as I go here. I should have been deleting them out of my window. There's a question here about reports. Like I said, we do have quantity reports that we can either give you simply a quantity, or We can also do cost estimates with that same tool. If you assign materials to the structure for like deck concrete, and you tell us what's substructure concrete and so forth, and those all have unit prices associated with them, we could also give you a cost estimate breakdown, and we give you a very detailed breakdown of that. So for example, for the substructure elements, we'll break it down to the caps, the columns, the footings, and then the piles or drill shafts would all be separate quantities, and they could each have their own material items, which would in turn have their own unit prices and generate a pretty detailed cost estimate. Can we add lighting? Again, that would be part of placing 3D cells out here. There's an auxiliary tab that has 2 different tools for placing 3D cells out here very quickly. One lets you basically place 1 cell at a time, probably at a station and offset. The other one, you can come in here and pick like the right edge of the deck and say, okay, I want to place this 3D light cell, this 3D light pole every 100 feet or at each pier line or something like that, and very quickly place a whole series of them in there. So yes, we can handle those quite easily as well. Let's see, I'm trying to follow up. Yeah, we do model the wing walls, and those would be included in the quantity estimates as well. So yes, we can, like I said, do just about any shape of wing wall that you have. I don't know that we handle 100% of everything out there, because there's the variations on those are about as far as they are wide. But we, I think, do an excellent job of handling just about anything you're going to need to be able to do for wing walls, and those would be included in the quantity estimates as well. We're kind of coming to the end of our time here. Hopefully I've answered everyone's questions. If not, my email is steve.willoughby@bentley.com. Feel free to drop me an email, and I'll be glad to answer those questions for you.